So you want to have both these equations written down along with your graphing grid. It's going to be a nice reference going forward. So when you see this kind of problem, first of all, let's make sense about what it's really asking us to do here. So when it says f of x equals that and g of x equals that, really what it's doing is it's just giving us two different equations. We're using f of x and g of x instead of y, partly because it helps us to differentiate the two equations. They both aren't saying y equals, so it shows that they are in fact different. The other reason why sometimes we'll use f of x and g of x, and f and g just tend to be common, it doesn't have to be f and g, is that we can write statements that look like this over here. We're solving f of x equals g of x. Function notation is often used in these terms. What it's really saying here is to find f of x equals g of x, it's saying treat this like a system of equations and solve it. In this particular case, that's by graphing. So in other words, your answer is going to be where they cross. So we're going to have to graph both of these in order to figure out where they do cross. Okay, so let's go ahead and start going through that. Let's go ahead and start by looking at the f of x. So we know f of x equals x squared minus 3. Go ahead and start by making that graph on your own. I think you got that solid. And then we'll go through it here together to make sure that you're on the right track. So to graph f of x equals x squared minus 3, first thing we want to note is that we got that minus 3 in there, and what that does, that tells us that this graph has been shifted down 3 units. So my first point then is down at 0, negative 3. This is going to be a parabola. I know it's a parabola because that x squared, that U-shaped graph as a result. And so that point, that first point that I plotted, is the vertex. Now from there, there's nothing else going on in this, so it's going to follow the same pattern as x squared always does. So 1 squared is 1, therefore I go over 1 up 1 on both sides. 2 squared is 4, so I go over 2 up 4 on both sides. 3 squared is 9, so over 3 up 9 on both sides. And over 4 would be up 16, because 4 squared is 16, but that one doesn't fit on our graphing grid. So go ahead and draw the curve through. We've plotted all the points we can on that, and we have our curve now. That's the first step in solving this problem. Now remember, we're trying to solve the system by graphing it. That means I need to see where does it intersect that other equation. So I need to make that out of the graph. And so if I'm going to graph g of x equals x minus 1, again, the minus 1 tells me that my first point is down 1. So we put our first point at negative 1. From there, I need to think about, okay, what's the shape of this graph look like? You notice it's just a plain old x. It's not x squared, it's not absolute value x, it's not root x or anything like that. Because it's just a plain old x, we know that the graph of this is going to be a line. Now, in front of the x, there's no number written. That means it's a 1. There's no vertical stretch applied. So from that first point, we're going to go up 1 and over 1. That's the default. If there's nothing multiplied out front, we go up 1 over 1. By the way, remember that number out front can also be described as slope. If you're thinking of it in terms of slope here, your slope is 1. Which again is a fraction is 1 over 1, so it's up 1 over 1. All right, and since this is a line, we know it's just going to keep following that exact same pattern of up 1 over 1. So you go up 1 over 1 all the way on the right side, and then on the left side we follow that same pattern. So then that means we're just going to be going down 1, left 1. Put in those points. I'm putting in the points here not because I absolutely have to see every single point in order to be able to draw the line, but rather because it's going to make the line more accurate when I draw it in. The biggest thing is knowing where those outside points are, because the further away the points are that you're trying to line up, the more accurate you're going to be when you draw it in. Now since this is a line, it's got to be straight. I suggest you use a ruler or a straight edge of some sort. Go ahead and draw in that line. Now that we have both graphs made, we're looking to now solve it. Because remember, our whole goal was we're trying to figure out where f of x equals g of x. And remember what that really means here. F of x is just the graph of the parabola. G of x is just the graph of that line. So if I want to know where f of x equals g of x, I look to see where do they cross. And so we're looking at those 2 points. So our solutions then are the coordinates of those 2 points. So then our final answer here is going to be 2, 1, and -1, -2. We do the graphs to figure out where they intersect. The intersection points are the solutions. Now write these 2 new equations above your next graphing grid, so you're going to have that down as we go forward and solve it. All right, so just like the last one, we're going to start this problem by graphing each of the 2 equations. So if you haven't already, graph f of x. So that's going to be -1/2 x plus 5. So f of x is -1/2 x plus 5. The plus 5 tells you that your first point is going to be up at 5. Then the -1/2, that is your slope, otherwise known as a vertical compression by a factor of 1/2, and a reflection across the x-axis because it's negative. The upshot, I tend to find it a little bit easier to think of it as slope, because here our slope would be -1/2. Remember, slope is rise over run, so it tells me from my starting point I'm going to go down 1, and then I'm going to go right 2. And then to finish making that graph, because it's a line, and again I know it's a line because it's just a plain old x, it's not x squared or anything like that. Because of plain old x, I'm just going to keep following that same pattern of down 1, right 2. Do that on both sides, follow the same pattern out, and draw the line in. Having drawn that line, you're done with f of x, and you're now going to go on to graphing g of x. So go ahead and now graph g of x. So for g of x now, we got that -1 on there. That's telling us it's been shifted down 1. That's where I need to put my first point. From there, I think about, okay, where do I normally go? Normally for square root, I'd go over 1, up 1, because the square root of 1 is 1. But in this case, I have that 2 out front of the square root. That means I got a vertical stretch by a factor of 2. So instead of over 1, up 1, I'm going to go over 1, up 2. For my next point, normally I would go over 4 and up 2, because the square root of 4 is 2. Okay, but in this case, I'm not going to go over 4 up 2 because of the 2 that's being multiplied by the square root. Again, that's a vertical stretch. So instead of going up 2, I'm going to go up 4 here. So that's where my next point goes, is over 4 up 4. And then I do want to finish out this graph. Sometimes these things behave oddly. We want to make sure that we can see the whole graph to make sure there's not more than one intersection point. So then my next point, I would go over 9, normally over 9 and up 3. But in this case, I'm not going to go up 3. Remember, I got that 2 out front, so instead of up 3, I'm going to go up 6. After that, it would be over 16. That one doesn't fit on our graphing grid, so I can go ahead and draw the curve through those points. We now have both graphs made. Now again, we're trying to solve f of x equals g of x. That means we're trying to figure out where do they intersect. And that's going to be our solution. So hopefully you can see where they intersect. The nice part is they both were points plotted nicely on each of the graphs. And so our final solution for this problem is 4, 3. 4, 3 is the solution. The graphs are the work we have to do in order to be able to get to it. For our last one here, we are going to be graphing f of x and g of x again. A couple different types of functions. Please write down each again above your next graphing grid. And like the previous ones, in order to be able to solve f of x equals g of x, I'm going to graph f of x and I'm going to graph g of x, and I'm going to look to see where they cross. So first of all, graphing f of x. It's an exponential here. Again, it's exponential because x is the exponent. We got that -5 hanging on the end. That means that the whole thing has been shifted down 5. With an exponential, remember exponentials can be a little bit different, so we really got to take our time and make sure to follow the process. I always suggest you start by drawing in that dotted line showing where it's been moved up or down. Do that every time you have an exponential. So on your paper right now, draw in that horizontal dotted line at -5. And then from there, we need to plot our first point. Now, remember that normally I'd put my first point of an exponential up at 1. That means it's normally 1 above that line, because normally that dotted line would have been here at 0. So that means my first point is going to be 1 above the dotted line. So that's where our first point goes. In this case, that happens to be at -4, because it's 1 above the -5. So our next point, because this is 2 to the power of x, we are doubling our height. So I just went up 1. My next point then is going to be up 2. So our next point is over 1, and now it's up 2 from the dotted line. If I go over 1 again, I'm going to double that height. So instead of going up 2 from the dotted line, my next one I'm going to have to be going up 4 from the dotted line. Okay, I just went up 4 from the dotted line. If I go over 1 from there, I'm going to have to go up 8 from the dotted line. If I go over again, how far up will I need to go? 16 from the dotted line. That one's just off my graphing grid. Barely off, but yes, it is off the graphing grid, so obviously I'm not going to have to plot that. Now, I do want to go into a little bit of detail on the left side, though, because sometimes this is where people have the trouble. If I'm doubling it as I go to the right, as I go to the left, I'm going to be cutting it in half. So if this is up 1 at the start here, if I go left, I'm going to cut that in half and only go up to 1/2. So I want to put that point in on the left so I can be a little bit more accurate as I draw on that curve. If it helps you to draw on more points going to the left, by all means do so. Again, they're each going to be cut in half, so that one's up 1/2. That'd be up 1/4, then 1/8, and it keeps going up by smaller and smaller amounts as we go. You can go ahead and put in those points to help you draw it in. But the big thing that you need to remember is that as we go left, it's going to get really close to the dotted line, but it never actually touches it or crosses it. Because anytime you take a positive number and cut it in half, it gives you another positive number. It'll never give you 0 or a negative. So then go ahead and draw in the curve that goes through it. As you draw in that curve, one thing I want you to pay special attention to, remember that our next point would have been up here someplace. It would have been just off the graphing grid. Your line, your curve that you're drawing in here, should not be crossing that next grid line. Because if it is, you'd be saying that that point is actually going to be on that line. All right, and then we now can go ahead and move on to the g of x. Now, g of x in this problem can be somewhat tricky to think about because g of x equals 3. There's no x in it. There's nothing like that in there. So what kind of graph is it going to be? Well, remember, g of x is behaving just like y. So what if I told you that y equals 3? Look at your graph. Plot a point where y equals 3. Just put a dot someplace where y equals 3. Most of you, when I say that, are thinking of that point right there. You're thinking of the point on the axis where y is 3. But that's not the only possible point where y is 3. Because x can be anything here. So where else could y be 3? Well, what if x was 1? If x is 1, y would be 3, right? So that point would work. In fact, x can be anything. And y is still going to be 3. So you notice that if we just have it be y equals 3 or g of x equals 3, it's a horizontal line. So that's your graph for something that looks like where it's just f of x or g of x or y equals a number. It's just going to be a horizontal line like that. All right. Now, remember that this is just the work that we do in order to be able to get our answer. We're still trying to solve out what makes f of x equals g of x. So we look to see where they cross, and our answer then is going to be at 3, 3. That happens to be where they cross here. So we know our solution is 3, 3, but I do want to give you one other little detail just because you're going to see some problems that look crazy complicated at times, and I want you to see actually it's the same thing as what we were just doing here. This process of solving it could also have been used to solve something that looks like this. I could have given you 2 to the x minus 5 equals 3, and you would have been able to do the exact same thing to be able to solve it. So whenever you see some of these crazy equations, one way to be able to solve it is graph one side, graph the other side, and see where they cross. Because really that's all it's saying. It's just saying, see where they're the same.